Let's discuss the behavior of real gases in nature. As just now you have studied about postulates or assumptions of kinetic theory of gases, that gives us the basic idea about real gases. Once again, we discuss precisely how real gases behave, or how when we perform experiments on real gases, the changes are considered. The very first thing about real gases we can state that the size of a molecule is not negligible, because of which we can state when we talk about volume of a gas, it is always less than the container volume. So always you can state when you change the quantity of gas in the same container, the gas volume changes. There is one analysis we need to always account. And another behavior for real gases we can state, due to some interaction between molecules, the gas pressure is always reduced. I think you might be wondering how it is possible due to interaction why the gas pressure is reduced. Let's discuss with the help of a diagram. Say if there is a container wall, we have discussed that gas molecules exert pressure on container walls due to continuous collisions. We know that when molecules collide with the walls and rebound, during rebound you can say always there is a change in momentum, due to which every collision exerts some force on the walls, because of which gas pressure exists. But if we talk about the layer of molecules which is very close to the container wall, which is actually going to exert pressure, the second layer behind the first layer, if some interaction exists between this layer and this layer, and say this interaction is attractive in nature, then we can always state, because actually the van der Waals forces which exist between the molecules of a gas are attractive in nature, due to which the second layer of particles will attract this first layer of particles. So when these will collide with the container walls, the collision force will certainly be less, because it is being attracted by the previous layer of particles. So we can state if some interaction exists between the molecules, which is actually there in case of real gases. So due to which during collision, the pressure exerted on the container walls by the gas will always be less compared to the case when the gas is ideal. This is another important factor we need to keep in mind. Another factor we can analyze about real gases is as some interaction exists between molecules, always we can state the potential energy of molecules is more than zero, it is not zero. Whereas in case of ideal gases, we assume that there is no interaction, so we can state always potential energy is zero. So always some potential energy exists. And based on the concept of collisions which we have studied, that actually collisions of gas molecules are not perfectly elastic. This implies continuously some energy losses take place. So we can state always some continuous energy losses exist in a gas, because during collision some energy dissipation takes place. Similarly, we can define at very high temperature when a gas is heated, we can state at very high temperature kinetic energy of all molecules is very high. So if kinetic energy is very high, we can state in this situation potential energy is negligible. Or even if it is more than zero but kinetic energy is very large compared to potential energy, it can be neglected. So at high temperature we can state a gas behaves somewhat like an ideal gas. Similarly, if we talk at very high temperature and very low pressure. So you can state in case of very low pressure, the density of gas molecules is very low. And when density is low, molecules are far apart. And in this situation, if separation between molecules is large, we can state here interaction is negligible because the interaction force between molecules is a short range force. So at low density or very low pressure, when the separation is large, interaction can be neglected. And we can state that in this situation, a real gas also behaves almost like an ideal gas. So you can keep in mind that here we can write thus at a very high temperature and low pressure, a real gas behaves like an ideal gas. It behaves like, not exactly, but we can state by considering these facts, we can start behaving like an ideal gas.